Okay, guys, so the domain of this guy, of this entire piecewise function, of the whole thing, is talking about your x values. Now, your x-axis is obviously the horizontal one. So, does it go that way forever?
What? Where?
Does it go that way forever?
Which one?
Does it go to the right, to the right?
Oh, yeah.
Yes. Does it go to the left forever?
No.
Yes, it does. Even though it's going down, it still continues to go to the left forever, doesn't it? Right? So when you're talking about your domain, you're talking about your x values, and it really does go that way forever and this way forever. So what do we say about that domain value? X is what?
All real numbers.
All real numbers. Now, sometimes, let me put the symbol for all real numbers. Sometimes you need to write some exclusions. Now, what do I mean by that? Now, this is an open dot right here, correct? This one's a closed dot, so it really does fill it in. In other words, if I asked you, does the x value of 1 exist on this piecewise function? It does exist because it's a solid dot up there. So if I said, for the input of 1, what do you get for an output? You get out 1, 2, 3, 4, 5, 6, 7. So for the input of 1, you get out 7. You don't get out 5 because that's an open dot, but you do get out 7, right? So sometimes you might have an open dot and an open dot, and in that case, you would have to say, but x cannot be 1. But in this case, it could be 1 because it doesn't have an open dot on both of them. It's open dot, closed dot. So does that make sense?
No.
No. It doesn't. Let me pause. The range is even more fun. Now, what do I mean by that? Because the range is going to be your y values. However, it gets a little tricky because, let me come up with a line right here real quick. Maybe give you a better illustration. Okay, so I have a line that shows me different y values here. So this would be the y value of -2, the y value of 0, the y value of 1, 2, 3, 4. You guys understand that, right? Okay, so where is my graph at in terms of y? Well, it's all down here for sure. So it looks like it starts here and it goes down from here. Does that make sense? So I would say that my y value is what? Y has to be less than what?
5.
Less than 5. Okay? So you're going to say y has to be less than 5. Not less than or equal to, because it's not a solid dot, it's an open dot. Now, what about this guy up here? Well, that's another y value altogether. What is that y value up here?
7.
It's just 7. So you would also have to throw this in. Y is less than 5, and you can use the word or. Y is equal to 7, right? But that's your entire range value right there. Y is less than 5 or y is equal to 7. Now, some of us are thinking, well, why can't I just say y is less than or equal to 7, right? Some of us are thinking that. And the fact is, that's wrong. Why? Because if I say y is less than or equal to 7, kind of lost my ability to move that line. Okay, so if I say y is less than or equal to 7, right there I really do have a graph on 7. But if I move it down, is there any y value of 6? No, right? There is no y value of 6 on that graph that I'm showing. So it's kind of like I have a gap right here. This gap between these two dots. So I would have to say, yeah, y is less than 5, but also y is equal to 7.